All right, so this should be part 2. You should have your periodic table. You should have the blue one and the one that you made out in front of you when you're about to do these. Key, you do need the blue one. The blue one is going to be important for this next part, talking about polyatomic ions. Okay. A few polyatomic ions that I wrote here. Here's nitrate. It's made out of nitrogen and oxygen, as you can see. So I got some nitrogen, some oxygen. I have ammonia. I'm sorry, ammonium. Got some nitrogen and hydrogens. Nitrite. This one is nitrogen and oxygen. And carbonate, carbon and oxygen. So I'll teach you where to find these and what do they mean. Polyatomic ions, they are made up of several different elements. Okay, these elements stay together in chemical reactions. The entire group has a charge, so it'll be a group of elements and they all have a specific charge. If you have to add a subscript after a polyatomic ion, it must be placed in parentheses first, and then the subscript is added outside of the parentheses. So this is a lot of information, so let's break it down and try to figure out what each of them mean. Looking at the blue periodic table, turn to the back. Okay? Turn to the back. On the left side, it says polyatomic ions. All of those are the polyatomic ions. Okay? And this is where we're going to find everything that we need. So let's look at our first example. Zinc sulfate. Whenever you see the word 8, right there, whenever you see the word 8, that means it's a polyatomic ion always. There are other ones, like if you look on the back of your periodic table, some of them say like chlorite. If you keep going down, cyanide, hydroxide. So there are a couple different ones, but a lot of them end in 8, ATE. So make sure that you know this. Zinc, we'll start with zinc. Zinc has a unique charge that it never changes. And since it never changes, the charge that this one's going to have is a +2 charge. +2. Sulfate, on the other hand, if we look at the back of the periodic table, on the left, it says polyatomic ions. You go down, all the way down, sulfate, sulfate, sulfate. It's the second to last one, sulfate. And sulfate has sulfur with 4 oxygens. And it has a charge of 2 negative, or I'm going to put -2. Okay? Now, SO4, this is one thing. This is one polyatomic ion. This isn't, you're not going to break them up and then mix and match. No, it's all just one. So when I cross my charges, this +2 is going to go here, and this -2 is going to go over here. So my formula will be zinc 2, parentheses SO4 2. Okay? But here I have 2 2's. You see that? I have a 2 and a 2. What are we supposed to do when we have the same number? You need to simplify it. Okay? You have to simplify it. And so I can divide both of them by 2. So my formula, here, I'll divide both of them by 2. So my actual formula is going to be zinc SO4. Okay? If you put the parentheses, that's okay. It doesn't matter. But without it is better. But it's still the right answer. Let's try the next one. Here I have magnesium and nitrate. So I know what magnesium is, because that's on the front of the periodic table. So I look. It's number 12 on the periodic table, Mg. If you forgot what charge magnesium is, remember, it's in the second row, so that it has a +2 charge. +2. There we go. Nitrate. Again, I see the word 8, so I know to look at the back of the periodic table where it says polyatomic ions. I'm going to go down until I find nitrate right there. right above nitrate. It's in alphabetical order. Nitrate. That is NO3 negative. Remember, negative just means -1. I'm going to cross the charges. So it's going to be Mg. And then parentheses NO3 2. You have to put the parentheses, okay? Because NO3 is one thing. When I'm crossing the 2, it's becoming 2 nitrates. So I have to put parentheses to know that there's 2 nitrates there. So I have 2 NO3s. That's what I want. Okay. So let's work through a couple more problems. Here I have sodium and cyanide. I want to put them together. So let's put sodium down first. Here is my cation, Na. So find Na on the periodic table. It has a +1 charge. Great. This is my cation. And it has a +1 charge. And my anion, this will be right here, cyanide. Cyanide, we look on the back of the periodic table, go down, there it is, Cn, -1. Okay? If I cross my charges, both of them will have 1s. Remember, we don't need to put 1s. So my formula, when I put them together, will be NaCN. NaCN. And that is my compound formula. So let's move on to the next example. I have lithium and sulfate. Lithium, so let's write my cation first. And that is lithium, Li, with the plus. And I have my anion, which is sulfate. Flip over your periodic table. Go down until you find sulfate, which is at the bottom. SO4 -2. SO4 -2. I'm going to cross my charges. Now when I cross this one over, I'm going to have 1 sulfate. So I don't need to put the 1, but I need to put the 2, and I have 2 lithiums. So the formula is going to be Li2SO4. So 2 lithiums, so I have 2 lithiums, and I only have 1 sulfate. Okay? Pause the video and try to do phosphate with barium. Okay, you should have paused it. If you didn't, you should have. We'll start. Barium. Barium and phosphate. First, which one is the cation? That means which one is positive. If you look at phosphate, I have the word 8 there. So that is on the back of the periodic table, and that is PO4 -3. So that can't be the cation because it's negative. So I need to find barium. Let's go to the periodic table. What number is barium on the periodic table? Correct. You should have said number 56. Number 56, Ba. Ba, Ba, and it has a +2 charge. My anion. Now this is going to be my phosphate. Flip over your periodic table to the back. Go to the bottom. There it is. PO4 -3. It says 3 negative, but it's the same thing. -3, 3 negative, potato, same thing. I need to flip my charges. So I'm going to have 2 phosphates, and I'm going to have 3 bariums. Okay? So let's write our formula. It's going to be Ba 3, and I need 2 phosphates. I need to put parentheses. PO4, 2. And there's my 3 formulas. Okay. Let's move on. Okay, pause the video now and try to do these 3. If you think that you got it, you can fast forward a little bit and see what the answers are. If you missed one, you should go back and watch the video on how I did that one. Okay? Okay, so now I'm going to go through each of them. So we'll start with the first one. Calcium hydroxide. I need to know which one is the cation. The cation is the one that is positive. We need to find calcium first. Calcium is number 20 on the periodic table, and that is Ca. Number Ca has a positive 2 charge, positive 2. My anion will be negative, and that's my hydroxide. There is no element called hydroxide. You got to flip over your table. You're going to go all the way down on the polyatomic ions and find hydroxide. There it is. It says hydroxide, OH negative. OH negative. OH negative means the same as OH negative 1. Now I'm going to cross my charges. So I'm going to have Ca parentheses OH 2. Because I need 2 hydroxides. Since I need 2 hydroxides, I got to put it in parentheses. Next, I have silver chloride here. My cation will be silver, Ag. Now, if you look for Ag, that is actually number 47. It looks like it doesn't have a charge, but it does. This one has a specific charge that never changes. Silver's charge is always positive 1. So let's put a positive 1 there. Boom. Here I have chloride. Now, if you look for a polyatomic ion, there is none that says chloride. Okay? There's a chlorate, there's a chlorite, but no chloride. What does that mean? Remember what we did the other day, Tuesday. What we did was, remember, we changed the ending to normal elements. If you flip back over to the front of the periodic table, where is chlorine? That's number 17 on the periodic table. And that's my anion, Cl negative 1. Okay? Don't assume that all of them are going to be polyatomic ions. Some of them can be normal elements. You have to look at the endings. So here I'm going to take my 1 and put it here. This one will go here. Since they're both 1s, they'll cancel out. And my formula, silver chloride, right there. AgCl. Next one, zinc acetate. My cation will be zinc, which will be Zn. I said in the beginning that this has a positive 2 charge. And my anion will be acetate. Here's that word 8 again. Let's flip over to the back of the periodic table. As you can see, it's the first one. Now this one has 2 different formulas. Let's just pick the first one. The first one looks cleaner, it looks nicer. Let's pick that one. And that formula is C2H3O2, negative 1. Remember, there's just a negative, that means negative 1. So I need to cross my charges. The 2 will go here, the 1 will go here. So I have 1 zinc. I need 2 acetates. Since I need 2 acetates, I need parentheses. C2H3O2 and 2. Boom. Now I have my correct formula. So here are the correct formulas for all three of them. Here are the last four. Pause the video and try to do these four by yourself. Okay? If you get stuck, it's okay. Just play the video where you're stuck and hopefully you'll get the answer. If you have all of them, look at all the answers, so fast forward a little bit. If you get all the answers correct, you can move on to the next part. We'll start here. Here's the word ammonium. Ammonium doesn't intonate, however, it is still a polyatomic ion. So what do we need to do? We need to flip over the blue periodic table to the back where it says polyatomic ions and go until I find ammonium. It's the second one. Ammonium is NH4. It has a positive charge, so positive 1. That's what that means. Plus means plus 1. Nitrate, here goes that word 8. I have another polyatomic ion. So I look still in the same part, go all the way down to nitrate, and that is going to be NO3 negative 1. Sorry, this is my cation, and this is my anion. Now I need to cross my charges, so the one will go here, the one will go here. Since they're both ones, I don't need parentheses. So it's just going to be NH4, NO3. No need to combine, just leave it just the way it is. That's the answer. Next one. My cation, strontium bromide. So let's start with the first one, strontium. That's an element. If you flip over to the front, strontium, number 38. That is what it is. SR. What charge does that group have? It should have a +2 charge. And then I have an anion, which is Br. Remember, not all of them are polyatomic ions. Bromide means it's just an element. Br. And that has a -1 charge. Cross my charges. And I have SR, Br2. Number 9. My cation. That's my positive one. That one's silver. Remember, I said silver always has the same charge. Silver is Ag. That is number 47. And I said that always has a +1 charge. Okay. Now I have my anion. If you look here, nitrite. Here goes that ITE. Flip over your periodic table. Look at the polyatomic ions. Go down. Keep going. There it is. Nitrite. That is NO2 negative. So NO2 -1. I'm going to cross my charges. They're both 1, so I don't need any parentheses. Ag, NO2. And boom. That's the correct formula. Last one on this examples. Aluminum permanganate. That's another cation. Anion. My cation is going to be aluminum. Let's go to the front of the periodic table. Aluminum. Number 3. Oh. Give me a second. Whoops. That was embarrassing. Aluminum. It's my first one. Aluminum has a +3 charge. That is number 13. So it's going to be Al +3. Okay. And then permanganate. Here goes that ending 8 that I talked about. So go. There it is. If you look on the back, MnO4. MnO4 -1. I'm going to cross my charges. This will go here, this will go here. I will have 1 aluminum and 3 permanganates. You need parentheses. Mn, O4, and I need 3 of them. Okay. And here are all my formulas. So please check and make sure that you're doing everything right, and then move on. Last part. Okay. We're going to name the compounds with polyatomic ions. So if I give you a formula, I need you to tell me the name. There are a couple steps. Step 1, write the name of the metal or ammonium ion. So remember, if it starts with ammonium or starts with the metal, you always start with what's first. And then you're going to write the name of the polyatomic ion. Do not change the name. So I know that when before I said change to IDE, you do not need to do that. Only with polyatomic ions that you just leave it normal. So let's look at the first one. That's good. Yeah, you can do that. Okay. First one. I have magnesium, Mg, and I have a PO4. Look on the back of your periodic table. Go all the way down. What's PO4 called? Phosphate. So this will be called magnesium phosphate. Okay? And that's how you do it. You're just going to break them apart and then name them. Let's do 2 more examples, and then you can try to do the rest of them on your own. This one right here, I have NH4, and I have Cr2O7. Okay? So there are 2 different things here. NH4, let's look at the back of our periodic table where it says polyatomic ions. NH4 is, if you look, it's ammonium. So I'm going to write the word ammonium. Ammonium. Cr2O7, that's a big one, so that has to be a polyatomic ion. So I'm going to look on the back. There it is. Cr2O7, -2. That is called dichromate. And I'm going to write dichromate. Nailed it. Next one. CaS. Ca, that would name the metal first. So Ca, which is calcium. S. This is not a polyatomic ion. This is sulfur. Remember, if I have a metal and a nonmetal, just like this one, calcium and sulfur, I need to change the end of sulfur. And I'm going to change it to what? Remember, you have to change the ending. IDE. Sulfide. I changed it to IDE at the end. Sulfide. All right. Pause the video. Try to do the other ones right there. If you think you got it, fast forward and see the answers that I put. If you are lost, continue to play the video and just watch me work each one. Okay? All right. So let's move on to the next one then. I have Li3PO4. My first one is Li. Li, if you look on your periodic table, is called lithium. PO4, on the other hand, if you flip over to the back, so Li is called lithium, and PO4, that is called phosphate. So we're going to put them together, and we're going to name lithium phosphate. Okay. Next one, I have CD. I have 2 things here, CD, and I have ClO4. CD is cadmium, number 48. Cadmium, and I have ClO4. That's a polyatomic ion. Flip over to the back. ClO4 perchlorate. Starts with the P, perchlorate. And so if we put them together, cadmium perchlorate. Next one. My positive in this one is Na, which is sodium. My negative is phosphorus. Neither one of these is a polyatomic ion. Do not forget how to name these. I need to change the end of phosphorus to phosphide in this case. So when you're naming them, it'll be sodium phosphide. Next one, I have KCrO4. KCrO4. K is potassium. CrO4, that looks like a polyatomic ion, so I'm going to flip over to the back. Let's find it. CrO4. There it is. It's chromate. Chromate. So I just named the metal with the polyatomic ion. Potassium chromate. Last one. I have NH4 and Cl. NH4 is one thing, Cl is another. If you look on the back, the polyatomic ions, NH4 is ammonium. Cl, that's a normal element. That's called chlorine. It's chlorine. I can't end the word in chlorine. You have to change the ending. So this one you change the ending because it's just an element. So not chlorine, but chloride. Ammonium chloride. Call me over when you finish this part.